All right, we're going to update our batching. We did a little bit. We tried to update our batching a little bit earlier today, and we actually good news. Check it out. This is actually pretty exciting. I thought it was a problem. But guess what? It's not. I was thinking that one of our back propagation had some issues where we weren't capturing all the data in the data set, but it turns out we are. It looks like we are actually fully scanning the entire data set completely, and we are ensuring that we're targeting the inputs to the right outputs. It's working the way we want it to, but it's not stochastic. It's not like what we call random, right? It's not random. It's like linear. We're like fully sampling. But you know what? I'm not sure if maybe it does matter a little bit. Maybe I think we should, because sometimes we should update our model, our machine learning framework in general, to support randomized batching. I think we should do that. I think that's a really good idea. We need an even distribution, a smooth randomness. Now we could do this in several ways. I think thinking like creating a range with like a range, and then we shuffle the range, and then we pull from the range based on the position of the element in the range. And so we enumerate the range essentially. So here, actually, let's see if we can make it happen. So I do have it. So it is working now. So this is, if we run it now, it works perfectly fine. We're in a good working scenario. Oh, I was playing right before stream started. I turned on, I increased the learning rate just to make sure things were looking good. So let's reduce that learning rate just a smidge. Okay, that's looking a little bit better. And we also need to update this. Previous streams, so over the past few streams, we have been successful in building our own deep learning. Thank you for the likes, you guys. Deep learning neural network from scratch. We built it from scratch. We were successful. We did it. You can see all of our algorithms. This is the most important algorithm right here that you see on the screen. You can see right here on the screen. This is where we succeeded. We built it. We did the backward propagation, which was the hardest part. I am so excited that we actually got it to work. And we just made a few updates earlier today. We made a few updates to get some of the parameters, the hyperparameters, into the right spot, so it's nice and tidy and clean. And it feels so much better now, because we had a whole bunch of things. We were using global variables, which you don't want global variables, right? Thank you, guys. Thank you for the likes. And so we turned it into parameters instead of global variables, and we did some cleanup on that. So now, what we want to do next, this is what we have to do today. This is the plan. We want to get our batch. Our batch is the application for your neural network. We're doing a toy data set. We're doing the MNIST data set. You're familiar with MNIST data set, which we're loading from TensorFlow because it is easy to import the data that way. They made it really easy for us, and then we're shaping the data so that way it fits into our model. And this is what our model looks like. All right, so what we're going to do now is we're going to see if we can get our predictions looking good. And then later here, we're going to update our batching algorithm to make it a little bit more snazzy. We want to add randomization, randomized batching. There we go. Let's randomize the batching. We have to do a couple of things. What they call it in AI or math terms is called gradient. It's called stochastic gradient descent, like that. Stochastic gradient descent. It sounds fancy, isn't it? Is the godfather algo of AI. Yep, stochastic gradient descent. You know what, Aziz? It is my favorite of all of them. It works so well. It's like a universal algorithm. It just happens to work amazing. It works amazingly. It works so good. And it's a multi-purpose algorithm, and it works on just about everything. I spent 5 years tuning and searching for that specific algorithm, and it turns out of all the different approaches you can take, SGD is the way to go. Stochastic gradient descent. And that's what we're trying to do here. That's what we're going to do. We're going to update this model. So right now we're not randomizing it, but we want to. We want to get the stochastic guy part of 3D. Okay. Custom backtesting. Okay, got it. So backtesting is different than back propagation in this case. There you go. That's what we need to know. And then okay, so then you provide some common commands. Check the backtest part just below. Okay, here we go. Custom backtesting. From backtest, agent trained, lambda, build. Okay. Backtest dash run BT. and then you print stats. Okay, so this must give us the performance or how well the model performed, how well it did. I think that's the answer. So that's actually pretty clean, but is this good? I don't know. We're going to find out. Is it iterable in this case, or are we going to have another error? Int object is not iterable. Uh-oh, we've got a problem, you guys. We got a problem. Where is it? On line 101? Oh, 101 epochs. We're just running in a terminal window. Okay, let's see where this thing is. Inputs, but inputs for inputs. Inputs. Oh, inputs. Link inputs. Okay. So this needs to be Friday. Different times in the day. So subscribe to get the notification. I'll try to go live throughout different times of the day. What is this? Zahir, we're a computer science, AI, deep learning, data science, cryptography, security. We do it all. We do everything because I've got this company that I've owned that has taught me a lot of technology over the years, and I'm teaching it back to the community. So subscribe if you want to see when we go live next. So I stopped doing it because it was too consuming. I had other things to focus on, so I stopped doing it. But I will give you all the ideas that I've come up with over the years. Kali Linux, Parrot OS, and Black Arc. These are the different Linux distributions that you could use for ethical hacking, you guys. We'll be doing some other things like that. Will it do it? And you can make a living do it. And it's actually really good. Here's the deal. Raul, just to let you know, trade algorithmically. You can do it. You can be your own quant. You can be a quant, you guys. Aspirations, you got it. Awesome video pace. Thank you so much, everyone. Discord and Havoc lately, by the way. Excellent. You was Havoc. You are Havoc lately, by the way. Okay, Havoc. We'll look for you in Discord called Havoc. Thank you. Hey, Akash, we're just headed out now, you guys. We're Akash. 1 terabyte data leaked. Oh, that's a lot of terabytes.